Alright, today's lesson is factoring. Alright, so another Algebra 1 and Algebra 2 review. Alright, so we're going to start off by factoring the greatest common factor. Okay, so that means we're going to look at each term and see what they share in common. So the first thing we'll look at is 51 and 17. And over here to the side, we're at greatest common factor. Alright, and then if you divide 51 by 17, it comes out evenly. So you have the greatest common factor of 17. And then we'll look at my A's. They both have A's, and I'm going to take the lowest exponent of A, which is A cubed. And then I'm going to look at my B's. Alright, so I have B4 and B5, so my lowest exponent is to the fourth. Alright, so greatest common factor is 17a cubed b4. From here, I'm going to take each term and divide by my greatest common factor. Alright, so factoring is basically division. So 51 divided by 17 is going to give me 3. So I have 3, and then A8 divided by A3 is A5, and then the B's will cancel out. Alright, and then 17 divided by 17 is 1. A cubed divided by A cubed cancels out. And then I'm left with B. So my final answer, when factored and simplified, apologize, I have to put that on the outside. So what I divide by has to go on the outside. Alright, so we got 17a cubed b4 times 3a to the 5 plus b. That is our final answer. Alright, so those are nice easy ones. Then move on to difference of squares. So some of our perfect squares we talked about in our do now the other day. Got 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49. That's 7, 8 is 64, 9 is 81, 10 is 100, 11, 12, 13, 14, and go all the way up to 15. That's all I expect you to memorize. Alright, so those are all of our perfect squares, and then our rules for factoring. So there's a shortcut. If we are given x squared minus y squared, so both terms are perfect, it factors out very nicely to be x plus y times x minus y. Alright, so for this example, if I look at it, so I'm going to look at each term. So square root of 36x squared, square root of 36 is 6, square root of x squared is x. Perfect. Then we'll look at 25, which is 5. Okay, so 6x becomes my x, quote-unquote x term, and then the 5 becomes my y. So this factors out to be, so we're using the rule x plus y times x minus y. So we get 6x plus 5 times 6x minus 5. Alright, moving on to the next one. So I'm going to take the square root of 16x squared. Square root of 16 is 4. I get x. Square root of 1 is 1. Again, 4x becomes the placeholder for x, and 1 becomes the placeholder for y. So all I'm doing is just looking at this formula here and plug it into that. Wherever I see x, I plug 4x in. Wherever I see y, I plug 1 in. So we get 4x plus 1, 4x minus 1. Final answer, difference of squares. Moving on to the sum of cubes. Some of my perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. 4 cubed is 64. And then that one goes up. Cubes are a little tougher to memorize. Alright, so there's a rule for the sum of cubes. If I'm given x cubed plus y cubed, this factors out to be x plus y times x squared minus xy plus y squared. So we need to check, like we did in the previous example, to see if they're perfect squares or not. Or cubes, sorry, perfect cubes. So I'm going to take the cubed root of x cubed, and that gives me x. I'll take the cubed root of 125, and that gives me 5. So x will be x, and then 5 will be the y. I'll go plug in to this formula over here. So first I'll do is x plus y, so it'll be x plus 5 times x squared minus x times 5 plus y squared, which is 5 squared. Then I just got to clean this up. So I get x plus 5 times x squared minus 5x plus 25. Boom, and that is factored. So, moving right along. First thing I can remember, checking the terms, see if they're perfect cubes. Okay. Cubed root of 8 is 2. Cubed root of x cubed is x. Cubed root of 27 is 3. Awesome. They're both perfect. That means we can use this rule. So 2x is my x, and then 3 is my y. Again, plug it into that formula there. So I have x, which is 2x, plus y, which is 3. Then I'm going to do x squared minus 2x times 3 plus 3 squared. Now simplify this row. First binomial doesn't need anything. 2x squared is 2x times 2x, which gives us 4x squared. 2x times 3 is 6x. 3 squared is 9. Alright, so if you see these, you got these nice rules. Copy them down somewhere so you have them. Alright, now I've got difference of cubes. So difference of cubes. So if I have two perfect cubes subtracting each other, this can become x minus y times x squared plus x times y plus y squared. Alright, don't expect you to memorize that. That's just the rule you can have on an index card or highlighted somewhere in your notebook. So same thing's going to apply. We're going to check the first term and the second term to see if they are perfect cubes. So the nice thing is when you take the cube root of a cube, it's going to be x. Cube root of 343. You can do that in the calculator by just doing 343 caret 1 divided by 3. Alright, I'll give you the same answer. Cube root of 343 is 7. So again, x will be x, 7 will be my y. Plug into my formula. Alright, going right there. This will be x minus 7 times x squared plus x times y plus y squared. So wherever you see y, you're just plugging in 7. Simplify it. X squared plus 7x plus 49. This, not usually, always, that trinomial there will never be factorable. All right, so the only way to solve something like that would be the quadratic formula. We're not doing that right now. All right, so cubed root of 8x cubed. We did this earlier already. We know this is 2x. And the cubed root of 125 is 5. So 2x is my x, and 5 is my y. So 2x minus 5 times x squared, 2x squared, plus 2x times 5 plus 5 squared. 2x minus 5 times 2x squared is 4x squared, plus 2 times 5 is 10x, plus 5 squared is 25. And that is how we do difference and sum of cubes. So again, check if you have two terms, check to see if they're perfect cubes or not, and then just plug into the formula. All right, now move on to stuff we're used to seeing, our trinomials. All right, I like to do what's called the slide and divide method, and that's when you have, so slide and divide if a is greater than 1. All right, so what I'm going to do is multiply and take first times last. I'll list my factors of 30 at 1 and 30, 2 and 15, 3 and 10, 5 and 6. Now I want to find a pair that adds to negative 13, but multiplies to negative 30. So some of you may think, oh, negative 3, negative 10, or make negative 13. But negative 3 times negative 10 is positive 30, or I need negative 30. So what I'm actually going to use is negative 15 and positive 2. Because 2 minus 15 is negative 3, and then 2 times negative 15 is negative 30. And for this one, a is 1, so it's just simple factor, x plus 2, x minus 15. Done. Factored. Alright, now just move along. Always want to do first times last. Get negative 14. List your factors, 1 and 14, 2 and 7, and that's it. So I'm going to find a pair that adds a negative 13. So negative 14 and positive 1 multiplies to be a negative, which is good, and adds to the negative 13. So I'm going to do x plus 1, x minus 14. Alright, so here my a is greater than 1, which is 2. So I'm going to divide. Okay, so I'll take those two terms right there and divide by 2. Alright, I'm going to simplify if I can. So x plus 1/2, and then x minus 7. Whatever you can't simplify into a nice number, you're going to slide it in front. So I'm going to get 2x plus 1 times x minus 7. Factored. Slide and divide method. Again, first times last is 90. 1 and 90, 2 and 45, 3 and 60, 5 and 18. So far nothing gets me to 21, and then 6 and 15. That makes 21, both negative. Good. So I'm going to use that. So I got x. I'm going to cut these. There we go. So I'm going to use x minus 6, x minus 15. Again, a is greater than 1, so I have to divide here. So divide by 10. Alright, this is the divide part of the slide and divide. So I'm going to simplify the fractions. So I get 2 goes into 6 and 10, so that makes 3 over 5. And then 15 and 10 is 5, goes into both of them, so that's 3 and 2. So neither of these broke into nice whole numbers. So I'll take my bottom. I'm going to slide to the left. So that 5 goes in front, 5x minus 3 times 2x minus 3. Fine answer, all done. All right, and then we got some other factoring, covers all areas. So this factor by grouping will be for letter C here. So I'll do this one first. So when you got 4 terms like this, you want to group the first 2 and then group the second 2. Okay, and then you're going to look for GCF. All right, so with 15 and 6, they're both divisible by 3. They both have x's. Lowest exponent of x is squared. So GCF there is 3x squared. So that'll come outside. 15 divided by 3 is 5. X cubed divided by x squared is x. 6 divided by 3 is 2. X squares cancel out. Second set of parentheses, 10 and 4, greatest common factor is 2. So that's going to pop out as a positive 2. And we get 5x plus 2. All right, so from here we're going to do same times the sum. And what I mean by same is what's in the parentheses. So same, all right, because they're both 5x plus 2. So I'm going to get 5x plus 2 times, and then my sum is what's on the outside. So starting left to right would be 3x squared plus 2. So when you got 4 terms and you can group them, hopefully they have a GCF, and if they do, you're going to get same times sum. I'm going to go back to A now. So I always want to look for a GCF. So 5 and 180 both have 5 divisible. They both have x. Lowest exponent is just 1x to the 1. So 5x factored out becomes x squared. And 180 divided by 5 is 36. All right, and if you look here, this is the difference of squares from the back at the beginning of the notes. All right, so you got square root of x squared is x. Square root of 36 is 6. So when we factor this, we get 5x times x plus 6 times x minus 6. All right. Last problem. For greatest common factor, I have a negative. I always want to get rid of negatives, so divide each term by negative. All right, and 6, 14, and 4, all divisible by 2. It looks like that's all I can do right now. So negative 2 becomes 3x squared plus 7x plus 2. Now I'll do my first times my last. It's going to give me 6 on the side. 1 and 6, 2 and 3. Need to make 7. So negative 2. I'm going to use 1 and 6 to make 7. So x plus 1, x plus 6. A is greater than 1, so we're going to use this. Alright, so this is our divide step. Simplify the fractions if you can. Whatever can't be simplified, remember, slides in front. Alright, so we get -2 times 3x plus 1 times x plus